So as I was saying, we're going to learn just a part of that theorem. So something we need for the full theorem that we will learn tomorrow. And the full theorem we learn tomorrow will be like the ultimate shortcut. That doesn't mean there's like no work to it or anything, but it is just even a little bit more of a shortcut. So it's called, today we're going to talk about the binomial coefficient. Yesterday we talked about Pascal's triangle. And in Pascal's triangle, those numbers were the coefficients, right? Do you guys know what I'm talking about? So what we'll learn today is sort of a shortcut for how I can find that number. Now, yesterday's assignment only went up to the 6th power, so that wasn't too big, but what if we have to go up to the 21st power? Do you really want to take your triangle to the 21st level? Maybe, some people do, but that's what the binomial coefficient will do, is it'll help us find that coefficient without having to extend that triangle. So we're going to first start with just a little bit of different pieces, and then we'll actually get to the binomial coefficient part. You guys already did your stat box? Alright, so first, before we get into all the theorem and all that, is factorial notation. Now, I'm hoping you guys have seen factorial before with that exclamation point. So, n exclamation point, when you're in math class, you're not going to say like n very excitedly, okay? You're going to say n factorial. So this exclamation point when you're in math class, that's called factorial. And so as long as n is greater than 1, n factorial is the product of the first n positive integers. So a general formula is n times n minus 1 times n minus 2 times n minus 3, all the way down to 3, 2, 1. Now it's a little bit abstract because we don't have any actual numbers in there, but we will put numbers in there so I can make a little bit more sense. Okay, I feel like you guys are almost done writing, so as per usual, y'all know I did not align the board. Alright, so here are some of those examples. So 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So whatever your number is with the factorial, you multiply that number by every single number that comes after it. Now, we will be practicing a few things without using a calculator, so it is important to know how to express that. But do you guys know where to find factorial on your calculators? So we're going to do some non-calculator, some calculator, but it's still important to know. So while we have factorial stuff out here, let's see, on these calculators, like the yellow ones, the one that Katie has, it's under PRB. On the graphing calculators, if you hit math, you can scroll over to PROB and find the factorial. Making sure, have you guys found it yet? Yep. I can't find it on mine. Sometimes I don't know where stuff is on that one. It's under PRB. Did you find it, Nicole? Yes. Did you find it? So we get math. And I used to roll the math here. I think probability. Okay. Now there's also kind of an example of this one, and this is the way they have it in the notes, but to me it's kind of backwards, so I'm just going to explain it backwards. So if I have 7 factorial divided by 4 factorial, this is 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1, and then 4 factorial. And what happens is, like, these can cancel out, so all that's left is actually 7 times 6 times 5. I copied it the way it is in, like, your book, but for me, I kind of work the other way, where I like to expand it and then cancel it out. And we will be doing some of that. Remember, we are going to do some stuff by hand, some stuff with a calculator, but it's good to kind of take a look at, you know, how that stuff cancels. And I bet the more you do it, you can probably jump right from here to here. For me, I still really like to see all the canceling. That's just where I'm at. But there you go, some kind of simplifications here. Okay. So the factorial rule says that n factorial is the same as n times n minus 1 factorial. That might look a little weird, but if we think about it, like with a real number, let's take 4 factorial. So that's saying that 4 factorial is the same as 5 times 3 factorial. I'm sorry, same as 4 times 3 factorial. Well, that would be 4 times 3 times 2 times 1. So it ends up being like the same thing. So just saying that you can kind of break some stuff off if you need to, and you kind of work a little bit with that. And 0 factorial equals 1. Now there's a really long explanation for that, but it's kind of akin to, you know how like anything to the 0 power equals 1? It's sort of the same. So if you want to, we can talk about the long explanation for that, or we can move on. Okay, it looks like we want to move on. So we're going to practice a little simplifying without a calculator to start, just to kind of get used to this stuff. So simplify without a calculator, 8 factorial over 5 factorial. So you might want to, you know, if you found a shortcut, you could do that. Otherwise, what I would do, I'm going to let you guys kind of start it on your own. Write out all the digits, 8 times 7 times 6 and so on, over 5 times 4 times 3 and so on, and see what cancels out. I know this isn't that way on the example, but when you're finished, multiply everything out so you just have like an integer answer. Okay, I think I might be the one that's wrong, so hold up. What do you guys get when you want to find that out? Me, not you. Okay, so if someone could grab that, that'd be great. So remember, if you're not sure, just start writing all of them. All over, and so on. And then we can see what cancels out the 1s, 2s, 3s, 4s, and 5s. So all I have left is 8 times 7 times 6. And if we do multiply that out, we get 336. Okay. All right, do you guys feel okay with that? Okay. All right, so we can try another one. 6 factorial over 2 factorial times 3 factorial. And again, I take the same approach where I like to write it all out, see what cancels out. You might be able to do a few rounds of canceling if that's how you feel. Okay, I see most of you guys have it. And remember, we are doing it without a calculator right now. Because yes, you could go to your calculator, find your little factorial, and plug that all in, but we're practicing without a calculator. So those cancel out. So you could keep going. You could do a little bit reducing too. Like I could say, well, the 2 and the 4, that will go down to a 2. So you could do some more reducing if you want, if that's your style. And then I'm going to end up with 6 times 5 times 2, which is 60. So whether you do that or you just kind of leave it without doing that little extra bit of reducing, you should still end up with 60. Are we okay so far? Because we're going to finally get to the binomial coefficient, so the part that will be in our formula that we will learn tomorrow, or our theorem we'll learn tomorrow. Okay, so this is the binomial coefficient. So we've got some notation here that's a little bit different. So when you see this parentheses, and you have n above r, so it's not really like a fraction, n above r, and n and r are going to come from the theorem we'll talk more about tomorrow. So today we're just going to practice with like numbers, but then tomorrow we'll use actual like problems that we'll pick n and r off of a binomial expansion, but today we're just going to practice with numbers. So the theorem is n factorial over r factorial times n minus r factorial. So what we'll do is we'll use this to find the coefficients of an expansion without having to use Pascal's triangle. It is a shortcut, and it is in your note packet. So let's see. Actually, we're still on that same page. It's been on forever. So the page that has all the sequence and series stuff at the very bottom, this exact thing is in your packet. So what I have copied is in your packet. You don't have to memorize it. You do have to know what factorial means and like how to figure that out. I want you to write something else in your notes as well by this. Where do I want you? I'm going to write it right here. It looks like this. So N, C, R. So just write that down and we'll come back to it. So we'll come back to NCR, but just write it with this section in your notes. So what this does is it will, if we calculate this, it'll tell us like the coefficient on a certain term, and that's what we'll get to actually tomorrow. But you'll be able to see like if I've got an expansion like to the 20th power, I can find the coefficient on the 3rd term in the list. And this is where you don't want to go backwards. I realized the reason later. Okay. So that's where you can like use it. So, okay, what's the coefficient on the 3rd number if I'm going out to 20 terms or something like that? But we'll get to that part tomorrow. So we can use the formula to evaluate. So if I have 6 above 4, you can look in your notes, you can look in your packet, and we can evaluate this. So then I have 6 factorial over 4 factorial times 6 minus 4 factorial. So I just follow the formula exactly for the binomial coefficient. And that, yes?
So, wait, do we subtract this and then perhaps
Yes, very good. So here you kind of said what I was going to say first, is you got to subtract that. So 6 minus 4 is 2, so it's 2 factorial. And now this becomes just like the last example we did. So in the last example we did, then we can do all the business. So we can do this without a calculator. And then we can cancel some things out. I'm going to cancel the 4, 3, the 2, and the 1 this way. And again, you can do more canceling, but if you don't want to, you could have, 6 times 5 is 30, divided by 2 is 15. So either way, if you want to do more canceling or not, it's really up to you. We're going to do one more example, but are there any questions or concerns? Does everyone feel like they can do this? Can you do it without a calculator? You're feeling okay? Okay. So let's do one more example. So 8 above 3. So use the binomial coefficient formula to calculate what that would be. And again, so this would end up being like, okay, what's the coefficient if I have an expansion up to the 8th power, and I'm looking at like, not quite the 3rd term, it would actually be the 4th term. But again, we'll get into that tomorrow. But you have to be able to do this in order to be successful tomorrow. Yeah. Yep, to start. Good. Okay, so 8 factorial over 3 factorial times 8 minus 3 factorial. So again, we all know where that is in our packet. We're good to go on that? Okay. So I kind of took a little shortcut. I know 8 minus 3 is 5, so I'll have 5 factorial here. I definitely like to cancel like the bigger part, so it'll cancel more. That's my style. And then, what's 3 times 2? So that'll cancel. So all I end up having is 8 times 7 over 1, which is 56. All right. So there's actually one other shortcut that the part of me that's like old school and it's like, you guys can do this without a calculator, doesn't want to tell you, but I'm going to tell you. So I would like you to take your calculators, and I'm pretty sure every calculator works the same way, so if it's not working out for you, we'll figure it out. So this was n above r, right? So it's n and r. So n is 8, r is 3. We're good on that? So I want you to type in your calculator is 8. The n number. What? That was hard. We're not done yet. We have like two-ish steps. So then I want you to type C, and you'll find NCR in the same place that you found your factorial button. So if it's under PRB or PROB, you should find NCR. So you should click that, whatever that is, whatever that looks like. And then you should click R, which is 3, and press enter. And tell me what you got. 56. Oh, look at that. So it is a combination. So it is on your calculator. You can go back and check on the last one. What was the last one? 6. So try 6C4 and see if you get 336. Just double check. Oh wait, it was 15, wasn't it? Right? I thought it was, right? I just was thinking of the previous example, which was something different. Okay. Well, that's the other shortcut. You're welcome. I kind of don't want to, but I did anyways. Okay, so what does our stat box have for us today? So what's the one thing that you want to turn back to this page and see? The one thing you'll think you need to remember. So whatever is like the biggest thing. Remember, in order to be successful tomorrow, we have to have like today's skill down because we'll use it as part of tomorrow's. And I'm going to be honest, tomorrow is like the day that it gets confusing. Everything's been like chill. Tomorrow's the day that might get a little tricky, so make sure you feel really good about A and B moving forward. And that is your practice assignment.